right, today's lesson is going to be putting all of our transformations together to graph sine and cosine functions with all of our possible changes. So we'll start with this graph of sine, and we've got an a value. Let me choose a different color there. Got an a value, a b value, a c value, and a d value. So all of our transformations there, and we've got a negative in front. So the first thing I'm going to write down about this graph is that it has been reflected, and that is over the x-axis. And for a sine curve, that means instead of beginning by going to a maximum value, we're going to begin by going down to a minimum value. Our amplitude, the absolute value of a, our amplitude is 2. That's the height of our wave. Our period, that is 2 pi over our b value, so we'll have to do a little keep change flip here. 2 pi divided by 1/2 is 2 pi times 2 over 1. So our new period is 4 pi. We only see half of a period where we used to see an entire cycle. The unit that we're going to use as we mark our x-axis would be our period, 4 pi divided by 4. So we're going to place a mark every pi to get our graph going. None of these changes will change the domain because it's negative infinity to positive infinity. But I'm going to put a pin in calculating the range because we've got some other things going on that we need to consider. Our phase shift, did we move the graph left or right? We have x minus pi. X is a liar, so we're going to go right by pi units when we go to graph. And we also have a vertical shift. Sorry that I left that off. Please write it down. We have a +1. So our midline is going to go up by 1 unit. So if our midline is at 1 and our amplitude is at 2, that would make the lowest value on our graph -1. If our midline is at 1 and our amplitude is 2, 1 plus 2 would give us a maximum value of 3. So let's think about how we're going to label our graph before we put all of these changes together. And I always start by doing the vertical components first. We've shifted our midline up by 1. So it's not really a part of the graph, but I want it there as a reference. So here's our new midline. And I got that range by adding 2 to the midline. Going up 2 takes us to 3, and going down 2 units is going to take us to -1. So our range -1 to 3. When we mark the x-axis with our units, we're going to make a mark every pi units. And we've got to get the whole cycle in there, which is all the way to 4 pi. So I'm going to go ahead and mark pi, 2 pi, 3 pi, and 4 pi. And the last thing I'm going to do before I get my final graph is graph everything except for the phase shift. So I want to have a good idea of what my graph looks like, and then I'm going to drag it to the left or to the right. So the sine curve starts at the midline, which is right here. It's not at the x-axis anymore, but it's been shifted up by 1 unit. And remember that this is a reflected graph. So rather than start by going up towards a maximum value, we're going to start by going down to a minimum value. And then the units that we marked on the x-axis show us all the important features. Back up to a maximum. And by the time we get down to 4 pi, we're back at the midline, and there is 1 entire cycle of our sine graph. But what we haven't done is shifted this to the right by pi units. So according to the way I've labeled this, 2 boxes are equal to pi. I need to take every important point and drag it to the right by 2 boxes. So this midline value is now here. Our minimum is down here. This midline has moved over 2 boxes. This maximum value has moved over 2, and this midline value has moved to the right by 2 as well. So now if we connect these green dots, we can see what all of those transformations look like together. So I start with everything except for the phase shift. Start with your midline and amplitude to scale your vertical axis. Use what you know about the period, dividing that by 4 to scale your x-axis. Sketch what your graph would look like, and then move it left or right as you need to. So let's try the same thing with cosine. And you might notice something different here. We actually have a pi in the equation. Let's look at where that is. So we have an a value. Pi is our b value. Here's our c value. And here's our d value. So as we go through, all of our changes have not been reflected. Don't have to worry about that. But our amplitude is 3. The period is 2 pi divided by that b value. So 2 pi divided by pi gives us a period of 2 units. So there's no more pi in our period, which means when we label the x-axis, we don't have to have pi units in there. But we do have to come up with some sort of interval that makes sense. So we've calculated our new period as 2. We always divide that by 4. So we need to put a mark every 1/2. Our domain is negative pi to pi. Sorry, negative infinity to infinity. The range, I'm going to put a pin in that because we haven't talked about the vertical shift yet, so we'll come back. Our phase shift, we have a -1. That means we're going to go to the right by 1 unit. And we do have a vertical shift. Please write that in. Sorry, I did not. -2, and that's very straightforward. We're going to go down by 2 units. Okay, knowing that our midline shifts down by 2 units, we're at -2, and then our amplitude is 3. So if we start at -2 and we go down 3 units, we are going to be at -5. If we start at -2 and we go up 3 units, we're going to be at 1, so our range is -5 to 1. Now let's go through and label our graph. I'm going to start with the midline, which is now at -2. Not part of our graph, so it's dotted. Our amplitude is 3 units. So we need to make sure our minimum is at -5. That's 3 units down from the midline. And that our maximum value would be at 1. That's 3 units up from the midline. And when we talked about labeling the x-axis, a little bit different because we don't have pi within our period anymore. We need to mark on our x-axis every half. So this is up to you. I'm going to go ahead and make every 2 boxes worth a half. So there's 1/2, there's 1. This is 3 halves or 1.5, and our period would end at 2. Now this is a cosine curve, not a sine curve. And we remember that when we sketch a cosine curve, we begin at a maximum value. So like I did with sine, I'm going to get the shape of the graph first, and then I'm going to shift it. Our cosine curve begins here at a maximum value, and our unit marks are going to help us hit those important features. It's going to come down. It's going to go to a minimum. It's going to come back up to the midline by this mark, and then it's going to come back up to a maximum by the time we get to the end of the period, which is just 2 units. But we need to shift our graph to the right by 1 unit. So what is 1 unit on this graph? It is 4 boxes. So we're going to move all these points to the right by 4 boxes, which equals 1 unit. So I'm going to take this maximum value and put it here. I'm going to take this midline value and put it here. I'm going to take this minimum value and move it over here. But we should be able to make sense of where the rest of the graph would be, even though these are the only points that we can get on the graph when we move it to the right by 1 unit or 4 boxes. So think about this pattern. Here's our maximum. It would have to come down here to the left because it's going to repeat itself. And then the next thing it would do would be go down to a minimum. So we can still see one full cycle of this cosine graph with a period of 2, an amplitude of 3, a phase shift of 1, a vertical shift of -2. Okay, so that's graphing with all of our changes, but we also need to write the equation from a graph. Like if we're looking at a curve, how can we figure out what are A, B, C, and D? So we're looking here at a curve, and honestly, I can't tell if this is a sine or a cosine curve. So we have some choices. I'm going to go ahead and figure out the amplitude and the midline. Those are usually pretty easy because to find the midline, we just want to slice this graph in half. And it looks like to me, and I think we'd be right, if we said the midline is at 1. We have shifted this graph up by 1. All right, so we know one of those transformations. And it's rather easy to count on this graph. You can use the formula if you wish. But we can find our amplitude by looking at the distance from the midline to the max or the midline to the min. That's 2 units. That's our amplitude. We can see it's also 2 units here. All right, now to do everything else, it's going to be, are we going to call this a sine graph or a cosine graph? And that all depends on whether you want to track a midline value or a maximum or a minimum value. And I'm looking here, I always like to look around, let's say the y-axis. And I don't see a maximum here, and I don't see a minimum here, I don't see a midline value here. That means that I can really make a choice. I can call this either a shifted sine graph or a shifted cosine graph. So if I want to write a sine graph, I need to look for something at the midline because that's where a sine graph usually begins. And I might choose this point. Now, from this midline value, the graph goes down, so I'd have to call this a reflected sine curve. If I want to go with a cosine graph, we can do that too. We look for a minimum or a maximum value. And the one I see closest to the y-axis is right here, but it's starting in a minimum value, so this would require us to write a reflected cosine graph. We could also go out here just to show you how many options you have. If we think about this as our shifted graph, this could be a regular sine graph. So here's our midline value. We're starting by going up. We've just shifted it to the right by quite a bit. We could use this point up here and call this a regular cosine graph, because a regular cosine graph starts at a maximum. It's just that that maximum has been shifted all the way to the right. So there are an infinite number of ways to write every periodic function. But in this case, we're going to start, I'm going to start with sine. So you can do either one. So we've figured out quite a bit already. Let's go ahead and call this a sine graph that we're going to write. Hmm, pen's not working. There we go. Our amplitude is 2. Now, we need to figure out how long a period is. And we can mark that from minimum to minimum. We can mark that from a midline to a midline, a max to a max. You can mark it however's easiest. Since I'm thinking about a sine graph, when I mark the period, I'm going to say, here's where my graph starts at negative pi over 2. And if we go through the whole cycle, we're following along, has to get back to that midline. It ends right here at 7 pi over 2. So from negative pi over 2 to 7 pi over 2 is 8 pi over 2 boxes. We got to add up all those boxes. Well, what is 8 pi over 2? The period is 4 pi. But that doesn't tell us what we're going to write in our equation. That's our b value. So let's do a little algebra here. We know that when we're graphing, the new period is 2 pi over b. Well, what we know is the new period and the old period. We know the new period is 4 pi, new period is, the new period is 4 pi, the old period is 2 pi, and we want to find b. So we're going to rearrange this equation. And we see that b is taking the old period of 2 pi and dividing it by the new period. So let's do 2 pi divided by 4 pi, and that's going to reduce to 1/2. So when we go to write our equation, the b value that changes the period is 1/2. Should also make sense. We're only seeing half a cycle within 2 pi units, where we used to see a full cycle. Midline vertical shift, we drew that in. That was up by 1. And our phase shift. So since we're writing a reflected sine graph, we're looking for that midline value, and it is at negative pi over 2. It's like someone took it from the y-axis and moved it over here. So we're going to have to put a phase shift into our equation that shows we've shifted left by pi over 2. And remember that this is reflected. So we're going to have to use a negative. So y equals. Since we chose to write a sine curve, and we're starting at this midline value, and we're going down first, we're going to need to put a negative out in front as we write our equation. Sorry, this is jumping all over. And then we're going to need to, there we go, put our a value, or amplitude, which is 2. Then sine. Then our b value, has the period changed? It did. It went to 4 pi, which means this is 1/2. And then a parentheses, and we have an x. And we put our phase shift in here, our horizontal shift in with the x. We moved left by pi over 2 units, which means this needs to read plus pi over 2. We close our parentheses, and any vertical shift comes at the end. We said that our midline was 1, so we could do plus 1. So just to show you how this would work with a cosine graph, if you chose that instead, you can absolutely do that. We saw that we could write a reflected cosine graph. So the amplitude wouldn't change. We said we'd write a reflected cosine graph. The period is still the same. The vertical shift is still the same. So let's go back to our graph and see how this would be different if we wrote reflected cosine. And we say reflected cosine because we're looking at this minimum value. Normally cosine starts at a maximum, so we flip that over. And all those other features stay the same except for the phase shift. And our phase shift here, if we write reflected cosine, is to the right by pi over 2 units. So when we come down here and we write this cosine graph, since we went to the right by pi over 2 units, we get minus pi over 2 inside parentheses. And if you went to Desmos and typed in these equations, they would be exactly the same. They would look exactly the same on the graph. So every time you see one of these periodic functions, you have a choice whether you're going to write it as sine or a cosine. Sine means you're looking for a midline value. Cosine, you're either looking for a min, or a max. All right, so one last practice with writing our sine and cosine graphs is this curve. You'll notice there are no pi's on the x-axis. That's okay. We'll take care of that by using what we already know. Let's start with midline. It's usually pretty easy to find. Midline looks like 1, so we've got a vertical shift of +1. Our amplitude, remember we can just look at that on the graph. So it looks like 3 units whether we go up or down from the midline. So our amplitude is 3. And now we have to make a choice. Are we going to write this as a sine curve or as a cosine curve? And I kind of want to make my life easier, not harder. So I'm going to say, is it easier to find a midline, or is it easier to find a max or a minimum value? So here's the midline value, but I can't really tell where that is. It doesn't line up so great, and I don't want to guess. Here's another midline value, but it doesn't line up so great here. Nope, highlighting. I'm going to do that. Can't really tell where that is. So I'm not going to write a sine curve. I'm going to look for a maximum or a minimum instead. Here's a minimum right here, and it's exactly at -2, so that's easy to keep track of. But this is a minimum value, so this would be a reflected cosine graph if we choose this one. If we come over here and look at the maximum value, this would be a regular cosine graph. The choice is yours. Let's go ahead and write a regular cosine graph. If this is a regular cosine graph, we can see that there is a phase shift. We've dragged that maximum value from the y-axis to the right by 1, 2, 3 units. So we know something about that cosine graph. We don't have to write a reflection in there, so we're going to go with that. So we know a lot already. The last thing we need to know from this graph is going to be the period. So max to max, min to min, get through one cycle and count it however you wish. Here are a couple ways you can count that. Here's a max, and here's a max. How long does this take? That's our period. -7 to 3 is a period of 10 units. It should work out the same if we go min to min, and it does. -2 to 8 is 10 units, so our period is 10 units. Now, we got to put this all together into how it impacts our equation. So we made a decision to go ahead and write a regular cosine graph. We discovered that the amplitude was 3, and our period is 10. No pi, just 10 units. Well, that's okay. Our b value is 2 pi over the new period. So our b value is 2 pi over 10, which reduces to pi over 5. So what you should take from that is that when the b value has a pi in it, then the x-axis will no longer have a pi. It gets canceled out. So our b value is pi over 5. Our vertical shift, we drew that in. That was the first thing we found. We went up by 1. Our phase shift, that totally depended on whether we wrote that reflected or the regular cosine graph. We're writing the regular cosine graph, and it got dragged to the right by 3 units. So we'll put that into our equation. And we should have, sorry, that's jumping around again, everything we need to know to write this equation. Y equals, no negative, we wrote the regular cosine graph. Our amplitude is 3. Now for our b value, pi over 5, parentheses x. Our phase shift, that maximum had moved to the right by 3 units. Remember, x is a liar, so we're going to have to write -3. And our midline, our vertical shift was up by 1, so +1 at the end. If we had decided instead to go with this reflected cosine graph, we could do that as well. Choice is totally yours. If we go with a reflected cosine graph, it changes our phase shift. We've moved to the left by 2 units. So just to show you what that would look like, Y equals -3, the amplitude doesn't change. Cosine pi over 5, because the period is still 10 units. But in this case, we were write x plus 2, then our vertical shift would be the same. If you went to Desmos, typed in both of these equations, they would look exactly the same on the graph.